Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about what is CPU scheduling in operating system and number of algorithms which is used in CPU schedulings one by one. Let's say what is CPU scheduling in short. It is a process by the operating system to decide which task or a program get to use the CPU at a particular time. Say for example, since many programs run at the same time, the OS needs to manage the CPU time so that every program gets a proper chance to run. The reason behind the CPU scheduling, there should not be any deadlock. All this process should not come in a queue. Come all together. It should come in a queue, and we are going to pick which particular process need to be executed first based on the algorithm. Right. The purpose of this CPU scheduling is to make the system more efficient and faster. That's the reason behind this CPU scheduling. Right. So now I am going to take the first algorithm, that is first come first serve. That is the first algorithm. Let's say we have primitive and non-primitive structure here. Say for example, non-primitive in the sense, so it takes each and every process which comes first with the longest burst time will complete the task. It won't leave the process unless it won't leave the critical section unless it completes the task, right? Primitive data structure, that is a primitive process in the sense it will interrupt the shortest burst time will interrupt the present current running process if it is comparatively priority has more than which is currently running inside the critical section, right? So in detail I will tell you about this non-primitive and primitive data structure in my separate video. Now let's get into the topic. Now here FCFS is always we need to call it as by default it is non-primitive. Why? Because whichever the process comes first, which have a higher burst time or lower burst time, never minds. It will complete, it won't leave this critical section unless the process has been completed. That's the point I need to make it. So here what is needed for CPU scheduling, right? The process decides which process will own the CPU use while another process is suspended. That's the point. The main function of the CPU scheduling is to ensure whatever the CPU remains idle and the OS has to least selected one of the process available in the ready to use. That's the point here. So now let's get into the process. You can see here, consider 5 process arrival time and burst time given over here. You can check it. P1, P2, P3, P4 and P5. See here, these are all the process. These are all the arrival times. Okay, so 4, 6, 0, 6 and 5. And the burst time. Burst time means time taken for a process to complete this task. Right. So these are all the process. Totally 5 process I have been taken. Right. Now what we are going to do is we are going to calculate average waiting time and average turnaround time with the formula. Right. So I am going to join. We are going to draw the first part. The step number 1 is draw a Gantt chart. Right. So here the Gantt chart we are going to draw. I have already drawn it because for a faster understanding, right, I have already drawn this thing. So here I have taken P3 first. Why? Because the arrival time for P3 is 0 comparing to the all the other process. Based on this particular Gantt chart has been drawn. Right. So this comes at 0. So P3 comes exactly number 1. And we are going to see how many minutes or seconds this P3 is running. It's running for 3. Okay, so it starts at 0 because the arrival time is 0 and it takes the critical section and it completes its task. Unless it completes the task, this P3 never leave the CPU. Right, so it complete the task exactly by 3 because the burst time is 3. Now you can just see that what is the next process which is getting entered. See the arrival time, which process is getting entered. P1 arrives at 4, P2 6, P4 6 and P5 at 5. So comparing to this arrival time, which process comes first? P1. So here you can check it. 3 to 4, no process has been arrived at CPU. You can check it. So there is nobody arrived at 3, right? So this is called as idle time. You can check it over here. This process 3 to 4. No process is doing anything. So the CPU, that is a critical section, is free. Nobody has been taken for execution. So this is called as idle, right? So this is called as idle time. Nobody will execute. So now the P1 is coming inside. So here it is, I'll adjust something. P1 is coming inside and its burst time is 5. So it takes the CPU exactly at the time of 4. P1 is coming inside. So what is the burst time? 5. So 4 plus 5, it ends exactly at 9. I hope you understand. So the next process which is coming inside, P2 is 6, arrival time is 6. P4 is arrival time is 5. And this P5 arrival time is 5. So comparing to this all the process, P5 arrival time is much early than the P2 and P4. So now P5 is getting inside. What is the burst time for this P5? Is 4. So it starts exactly at 9 plus 4, that is 13. I hope you understood. Right. Let's get into this particular process. P2 arrival time is also 6. P4 arrival time is also 6. Now what to do if both the process arrive at the same time? Here there is a technique, that is, same time, any process which arrived at the same time, pick the smallest process ID. So P1 and P4, which is the smallest ID? Sorry, P2 and P4, which is the smallest ID? P2. That's the point here we need to make. So that is the reason P2 is coming inside. Now what is the burst time for P2? 4. So it starts at 13, 13 plus 4, 17. So P2 ends at 17. You can check it, no process is interrupting any other. It is running in sequence based on the first come first serve. That's the point. So finally we have this P4 and its burst time is only 2. So it starts at 17, it ends at 19. So this particular chart plays a very important role, which is going to lead you to find total waiting time and waiting time, right? Total turnaround time and waiting time. Now the formula here, it is very clear. You can check it. Turnaround time is equal to completion time minus arrival time. So this is the formula to find a turnaround time. Waiting time is equal to turnaround time minus burst time. Let's check. So I will show you some examples so that you can understand. Let's see. I have drawn this for a compact understanding, right? I have taken all the process. You can see that I have taken all the process, completion time of all the process. Say for example, P1 completion time is 9. So I have mentioned it as 9. P2 completion time, it completes all the process. So P2 completed at 17. So I have taken it as 17. P3 completed at 3. So I have taken it as 3. Right? Now see, what is the formula for, let's see, for P4 and P5 respectively. You can check it. Okay. Now P1, its completion time is 9. So what is the turnaround time formula? You can check it. Turnaround time we need to find for each and every process and waiting time for each and every process. Now let's take P1 is completion time is 9. What's the formula? Turnaround time is equal to completion time minus arrival time. So what is the completion time for P1? Here it is 9. So we have already mentioned this. Minus what is the arrival time for this P1? Let's get into this chart. So what is the arrival time for this P1? 4. So 9 minus 4. The answer is 5. I hope you understand how this turnaround time is calculated. So I'll do for one more thing. So one more process. So what is the completion time for P2? P2 completion time is 17. So I mentioned is 17. So turnaround time formula is completion time minus arrival time. So completion time is 17 minus what is the arrival time for P2? So I can check it here. Arrival time for P2 is 6. So 17 minus 6, the answer is 11. So we found what is turnaround time and what is turnaround time for process 1 and process 2. So respectively for P3, P4 and P5, you can find it, just a numerical subtraction over here. So let me tell you how this waiting time is calculated. You have a formula. Turnaround time minus burst time is called as waiting time. That is, every process is waiting here how long? right? If it is just arrived and started processing, if it is just arrived and waiting for a longer period of time, I will prove that now. So for example, I'm going to take P1 and its turnaround time is 5. So 5 is already there, minus burst time. What is the burst time for this particular P1? You can check it. Burst time for P1 is 5, right? So 5 minus 5 is 0. Let me prove this P1 is not waiting anywhere. You can check this. This is a Gantt chart. You know that P1 arrived at 4, right? And it starts its execution at 4. So that's the point. See here, P1 arrives at 4, and here also you can check it. P1 starts its execution at 4. Let me prove that P2 is waiting for some more minutes comparing to P1. Let me prove that. See here. So here turnaround time for P2 is 11 minus burst time. What is the burst time for P2? You can check it here. The burst time for P2 is 4, right? So here you can check it. 11 minus 4. The answer is 7, right? So let me take you to the Gantt chart. Where is P2 here? Here it is, right? It is waiting for how many minutes? You can check it over here, 7 minutes. And what is the arrival time for this P2? 6. You can check it over here, 6. Even though it arrived at 6, so 6 is somewhere here, for example, right? When this P2 is started executed? 13. Okay, if you can calculate from 6 to 13, what is the answer you got? This one. So this is how I want to prove you, that is how long each and every process is waiting for the completion process, right? So I hope you can able to do this P3, P4 and P5, right? So now we are going to calculate the final part of it. Say this is the calculation, whatever we did in this particular, I will show you that whatever we did here, I have explained that in step-by-step process. You can check it. So for each and every process I have taken and I have proved that how this turnaround time and waiting time answers are calculated, right? I hope the overview of the video, why? Because it is a simple numerical addition and subtraction, right? Now finally we need to find the average for turnaround time as well as waiting time. So I'm going to take all the answers, that is for turnaround time. See here, I'll show you that turnaround time. I'm going to take 5 plus 11 plus 3 plus 13 plus 8. That is what here. So the final answer is 40 divided by 5 is equal to the total average turnaround time for this FCFS CPU scheduling is 2 units. And you can check it over here. Waiting time is equal to, again I am going to calculate 0 plus 7 plus 0 plus 11 plus 4. So total 22 divided by 5, the answer is 4.4 units, right? This is the average waiting time for different other process, right? So I hope that you understand how the CPU scheduling for FCFS is actually working. So this is the overview. I'm going to show you people again. And this is how the values has been calculated, and it starts from every P1, P2, P3, P4 and P5 will be having turnaround time formula, and adjacently you can find waiting time formula. And finally I have stopped exactly by calculating the average total turnaround time. I hope you understand the video. Thank you.